here to learn magnetism, Icse class 9 chapter 10, and this is the first part of the video. I am dividing this chapter to 3 parts, okay? So let's get into work with the first part. What were magnets? Pieces of lodestone, iron ore, Fe3O4. 3 names, yeah. Magnets could also be told pieces of lodestone, iron ore or Fe3O4. The formula for iron ore is Fe3O4, as you would be knowing. It has just two properties: to attract and to rest at north-south direction when set freely. So remember a situation that this is a pole and here I am attaching a magnet. So it will spin and at the last it will come to north-south direction. Now, magnets were replaced natural magnets were replaced to artificials. Why? Because artificial magnets were very strong and we could get artificial magnet in convenient size and shapes. So these two are only the reasons why natural magnets have been replaced to artificial magnet these days. So now, like poles repel. They don't like each other, so they repel. You can assume that like poles are two women, and women are always jealous to each other, you know. So like poles are women, unlike, they never fight with each other, they live with harmony, so they are men. Okay, so like poles repel and unlike poles attract. So now a magnet is always dipole. Now what do you understand by dipole? So dipole means if we break this magnet to two halves, you think that I have breaked it from here, so this will be south, this will be north. No, it will divide itself like this. It can never be its single pole. It will divide each other to two poles. Okay? Now, induced magnetism. What is induced magnetism? If you bring a magnetic material near to a magnet, this is a horseshoe magnet, let me be more precise. If you bring it near to a magnet, it will attract each other. This is a iron nail. It will attract each other. Yes? So, definition becomes temporary magnetism acquired by a magnetic material when it is kept near or to contact with a magnet, then it comes to induced magnetism. So a simple definition is, अगर आप कोई भी मैग्नेटिक ऑब्जेक्ट को मैग्नेट के पास रखते हैं तो उसमें मैग्नेटिज्म जाग जाती है, जिसे हम इंड्यूस्ड मैग्नेटिज्म बोलते हैं. Now two properties of induced magnetism: it precedes attraction and it's temporary. It's temporary in the sense this is a magnet. A magnet has a attraction till 10. A magnet would only attract till 10, and then the weight of this pins, iron nails, increases to 20. it goes on attracting, and it goes to 20. So this magnet would have no more force to attract these pins which have higher weight than this magnet's force. So it will leave them, and this becomes temporary magnetism. A proper line for this: this force only continues till force of attraction of magnet is sufficient to balance the total weight of the magnetic pins. So now induction precedes attraction. So now this is a magnet, these are the pins. Okay, so now if this is south, it has to be north, then only attracted. You know, men, unlike poles. So this is the other pole, south. Now if this pin has to be attracted to this, it has to be north, and this has to be south. So the process continues to go on. Okay. Now this opposite polarity is happening. If north attracts to south, we can say they have opposite polarity, and if south attracts to south, we say it has same polarity. So with opposite polarity, they all attract each other. So it has induced magnetism, induction. So induction is taking place first, and then it is attracted to the magnet and attracts to the magnet. So induction precedes attraction. Now, last topic of today. Definition of magnetic field. This is a magnet. This is the magnetic field. Assuming, I don't know what is the real magnetic field, it could be measured by scientists. So if I explain, this is the magnetic field. This is the magnetic field. So the space around the magnet, this is the space around the magnet. Yes, the space around the magnet in which if we come put a compass here, needle, with a needle, rest in geographic north-south. It rests in geographic north-south when set freely. Yes. So we can say this is the only principle why we use magnets in magnetic needle. You know, the compass of needle of the compass is made up of magnet because it sets itself in north-south direction when it is kept free. So here it is. So it rests in geographic south, north-south direction. Then it is called, this much is called magnetic field. The definition is the space around a magnet in which a needle of a compass rests in a direction other than north-south is called magnetic field of a magnet. Now, a magnetic field is not empty. Yes, it contains magnetic field lines. Now we are going to learn the 7 properties of magnetic field line. The first is, it is closed and continuous curves. This is magnet. It is, the magnetic field lines are closed here. Yes, closed. Yes, so it is closed. There is no more point it can move. So here only it's come. So it closes. It closes here. It's its exit point. So, and it is continuous curves. It has curves. It is continuously curved. So first property is clear. It is closed and continuous curves. Second property is outside the magnet. Outside the magnet. Outside the magnet. It is directed from north pole to south pole like this, in this direction. In this direction it goes. This is the second property. Now third property you can understand by the diagram of this second property. Tangent at any point of the field line gives the direction. Yes, the tangent means an arrow. Tangent is an arrow. So arrow at any point would give me the direction of the magnetic field line. See. Don't see this. See, a magnetic field line is given. If I draw an arrow, I would get its direction. Yes, it's very easy. Now fourth point is quite important. Second and third are related. Yes, fourth point is quite hard. Understand it. They never intersect each other. A magnetic field line is going on, it's going on, it's going on, it's going on. But here at the point they will never intersect each other. Application based questions of this could come of fourth property. Yes. Now coming on to the fifth property. They are crowded near the poles. Yes, of course. North south. Like this, like this, like this. Like this, like this. But eventually, where is the crowd you can see? Here, in the poles. So they are crowded at the poles. Where magnetic field is strong here. And magnetic field is not strong where the lines are far away. So, in the middle of the field there are weak and here they are strong. Sixth point. They are parallel to each other and the distance between them, the distance between the lines would be equal. If this is 5 cm, this would be 5 cm, if this would be 5 cm. Distance is equal and so we say equidistance and they are parallel to each other. You can see parallel and they are uniform. They are uniform to each other. They behave like a stretched rubber band. The last and the most important point. They behave like a stretched rubber band. How? This is a magnet. This is its field line. Now, here, see this is south, this is north. And if you bring another magnet, so south would repel, yes. So if you bring this another magnet, it will also have these field lines. So coming to the fourth property, they would never intersect. Then how is this happening? If you bring two magnets, its magnetic field line contracts. It becomes inside. અંદર વયું જાય અને અહીંયા એમ જ થાય. They don't like touching each other. So they would contract. This magnetic field or this magnetic field would be coming inside. It will be smaller. Its area will become smaller. Are you getting my point? Like stretch rubber band, they will go down. If we stretch, the area decreases like that. Now, what have we learned today? A small recap. What are the pieces of magnet? Lodestone. Second, it is dipole. No magnet could exist without a pole, without only one pole. How artificial magnets replaced natural ones. 4. Like and unlike poles. 5. Two properties of magnets. 6. Induced magnetism. And its two property. Attraction 1. Induced magnetism precedes attraction and it's temporary. Now 7th. Magnetic field and definition. It is a vector quantity, remember. Now, and the 7 properties. First one, closed. Go. They are directed from north to south. Third, tangent. Tangent at any point gives the direction. Fourth, never intersect. Crowded at poles. Equidistant. Parallel, uniform. And they behave like a rubber band. So if you like this video, you can take a snapshot. If you like this video, please comment. I value your comment and I will give you a reply. Please comment, like, share and subscribe.